very good evening to everyone and welcome to today's e-Disha session. I hope everyone's doing well in these tough times. My name is Anirudh Iyer and I'm a final year undergraduate student pursuing my bachelor's in information technology from Vivekananda Education Society's Institute of Technology. I have the immense privilege of moderating today's webinar on recommendation systems using AI. Have you ever wondered how you knock YouTube's door for just a video on some topic and end up killing hours of your day just watching the recommended videos? Or you hook onto Spotify for your favorite music track and end up increasing your favorites list? This session will help explain the working of recommendation systems and how industry giants like YouTube, Spotify, and Netflix provides users with a personalized catalog of content which makes them more riveting for us. It gives me immense pleasure to introduce Mr. Vishal Israni, who graduated from Visit last year and is currently working with JP Morgan Chase and Company. With his profound technical skills and a very keen interest in extracurricular activities, Vishal was selected as the Senior Deputy Cultural Secretary, where he played a key role in a large number of events and also helped organize Best AI-thon, a 24-hour national level AI-based hackathon, which certainly was another feather in his cap. Before I hand over the mic to Vishal, I'd like to encourage the viewers to actively participate in this session. If you have a question for our speaker, please feel free to post it as a comment under the live chat box. So without any further ado, I'd like to kick off things by welcoming our speaker. Vishal, over to you.
Hi, I chose this topic because it's doing wonders in the corporate world and is also one of the key aspects of the modern digital era. Speaking of today's agenda, I'll be starting with a bit about AI in general and then we'll be jumping onto the topic of focus, that is recommendation systems. I'll also put a glimpse on two of the major topics under AI, that is chatbots and OCRs. And since most of the juniors from various departments are still in touch with me and they keep asking me about placement guidance, I thought of covering that as well. I'll be not presenting anything about it, but I'll be surely addressing any questions in the Q&A section. Okay, so let's get started. I believe by now the buzz of AI is so much that almost everyone in the tech world is aware of the term what is AI. But most people don't dig deep to the roots of AI and declare it to be the most complex workaround for programmers. The need arises with an aim to save human effort and give the capability to a machine to perform human-like actions. Now, what makes it different from trivial programming languages? I'll put that in simple words. If you were to develop a basic arithmetic calculator using trivial programming, you would define the action that a machine is supposed to perform. So for every operator, addition, subtraction, multiplication, division, or anything like that, you would have to tell your machine via your code the action that is expected. That is where the self-learning and adaptive nature of AI comes into picture. You teach it how to perform an addition, it adapts itself to learn and provide expected results in future. There has to be accuracy issues at the beginning, and that is where the importance of choosing a right training algorithm in a proper fashion plays a key role. A training algorithm would be something that helps you train your model or your machinery to perform human-like actions. Considering a very real-life example, if a robot based out of normal programming was to make tea for two people, it would require the amount of water, milk, sugar, and tea powder along with the time that it has to keep it on the flame. And again, if this time it is not expected to make tea for two people but for seven people, it would require the above data in a modified fashion to make it perfect for seven people. And every time it is expected to make tea for different amount of people, different number of people, it would like just ask you for the data all over again. But with the blend of AI, the robot now is able to make those decisions based on the past inputs and the actions performed. I stress the word input because at the start it might just fail or might give less accurate results as well. But in long term, it learns and adapts to things. This concludes to one thing, that normal programming requires data and set of rules to process the data and give you the results. Whereas in AI, the data and the initial rules are enough, and it has the power to improvise based on the feedback after each output. Talking of feedback, what happens is after every iteration or every systematic periodic time, your application would just ask for feedback, and based on that feedback, you need to tweak your algorithm, your models to provide a better efficiency and accuracy results. Okay, that's okay. But what is the need of such a complex methodology? I'll put some light on that. I recently read a use case where an intelligent refrigerator is capable of making decisions. Hmm. And these decisions are normal. Consider the busy, hectic, fast moving day to day life where you have to have a work life balance. And this intelligent refrigerator assists you by training itself based on the past data and the required food items for the week. Let's say you usually cook the same thing related to milk every Wednesday, and due to certain XYZ reasons, you don't have enough milk this week. The refrigerator pops up with a message to get extra 1 liter milk this week. Or it analyzes the amount of veggies you consume and provides you a list to get from the supermarket for this week. Or it just processes all the available products in your refrigerator and tells you what all food items can be cooked from these available ingredients. So you just like have certain amount of ingredients and products in your refrigerator. It would come up with a list of items that you can cook based on the available ingredients. One more. You say you need to prepare biryani and it does a check and prompts with peas and cloves are missing. Yes, that all is possible with AI, and it comes with a blend of object recognition domain. Talking of automatic washing machines with a blend of IoT and AI, they are possible to decide the amount of water, detergent, and the time that it takes to spin for based on amount and the type of clothes you put into it. And it gets you everything done on just one click. You just put your clothes and it would decide the amount of water, detergent, time to spin and everything, and gets you your dried clothes just like that. And with the advent of technology in the finance world, there's a lot of development happening for algorithm based trading, where these bots would just decide everything and trade in stocks, and they get you your profit in your pockets. Awesome, right? Now, let's jump onto the key area for today's session, recommendation systems. This is a very unique touch base of the modern era, and they have become a trending escalation in the world of technology. The personalized touch to the content delivered to the users makes it significant in the digital market. And the reason behind this is its increased revenue, because these systems deliver actual value to their customers and they provide a scalable way of personalizing content for users. In short, it helps deliver what the users like. And it adds value because it resembles a lot of day-to-day life actions as well. We ought to watch a TV show, get a new phone, try out a new restaurant, and we ask our friends for the recommendations, right? Because there's a chance of having a similar taste. Netflix, with the world economy with the world economy is drowning due to the pandemic outbreak, this giant is ruling the market. All because of what it is known for: great UI and recommending stuff like no one else. YouTube, the guru of content. Why is it that you take a 10-minute mind refreshing break to watch a small video and end up spending hours on it? Zomato perfectly notifies you of your favorite restaurant nearby, your current location, based on your past taste, and you tend to like that as well. Instagram, the social media ruler, like any other all-rounder, has everything to need to kill your boredom. Suggest you friends, pages, codes, posts, places, and whatnot. There happens to be a virtual network bubble of your name. Basically, every user linked to various other things you like, and they manage to make you stick on it for hours. Spotify, in the presence of key players like Ghana and Savan and many other free content providers, Spotify has gained popularity only and only because of its recommender engine. You see, everywhere, content is the king because it provides value to the customer and brings the business to you. With all this happening around the world, where is it that you can hit a master stroke? Here is where. Ads. Organizations out there are looking for analysts to make their content profile based. Instead of simply spending lakhs on an ad which makes no impact on the target audience, the corporate world is moving towards research of these profile based ads for hitting it right at the spot. Why is it one being from a technical background keeps witnessing these ads about Eureka, Unacademy, Udemy, and all that? Why is it you spend few minutes on Amazon or Flipkart and in no time Facebook shows you an ad for the same? Why is it that the telecom companies keep sending personalized data packs for active users which vary from person to person? Another example would be customers who bought this also bought this XYZ product. Every e-commerce customer must have seen this statement on platforms like Amazon and Flipkart, and it actually helps them gain the customer base as well, right? It's natural, right? If you're purchasing a mobile phone, you would be looking for a cover for these smartphone, and these smart platforms have got their steps done right, and they show you what exactly you like. Even in a physical supermarket store, you would find related items sorted in a place that it makes way convenient for the user to navigate through. You would never find a bread at one corner of the shop and butter at the other end. These small things make a customer happy and brings potential to the business as well. Now that we have a base of fundamental aspects, let's march towards the technicalities of it and understand how is it done with the help of these popular algorithms in the back end. The key metric here is distance. The similarity metric. Yes, the distance is everything. It's the distance between different parameters, and the approach to calculate this distance make these algorithms different. How similar two objects or persons are is what is used as a primary parameter to bring out this delightful output. The major ones being cosine, Jacquard, Euclidean, Minkowski, and few others. Which measure is suitable more depends on the attributes for which you are trying to relate and find a correlation between. The primarily algorithms used are content-based, collaborative, and hybrid. Let's have a look at each one of them. Okay, uh, so content-based, yeah. Content-based filtering with an example would be a guy liking HRX clothing has a more chance of choosing footwear of the same brand, right? It basically comes with the trust in the brand. So there is a chance if recommendation systems are used while shopping with a particular brand, the same customer is shown the footwear of the same brand as a primary search under the respective section. It is also termed as cognitive based filtering and is known for comparing the content attributes of the item under consideration and the user under profile. So what happens is, if like let's say you are supposed to make a movie recommendation system, we'll come across this example in the later section, that if some person likes Christopher Nolan's movies, there is a high chance that the person would be recommended with those movies more. Same goes with YouTube, right? The more sad songs you listen, the more it recommends Arjit Singh to you. What actually happens in the back end is the profile and the object. By profile, I mean any user that is the consumer of your recommender system, and object for which you are trying to recommend stuff. What happens is this profile and object both are categorized based on certain attributes. Imagine a data for a user stored under and under this liking section. It's a let have Nawazuddin Siddiqui as his favorite actor. And on the other hand, we have a list of movies or TV shows having Nawaz's name in the cast section. So these both attributes are mapped via a link, and thus content like Sacred Games, Gangs of Wasseypur would be recommended to that particular user. So considering the Amazon or Flipkart example, your profile, if you are like buying more of United Color Benetton's clothes and all, your the liking under your name would be more UCB, UCB, UCB. And when it comes to searching any of the applications, any of the products online, you there's mentioned that you are UCB fan, and thus UCB would be more recommended to you. This is how these links are getting generated to correlate a user profile and the object or the content. And to build this correlation, the algorithm makes use of cosine similarity between the user and the item under consideration. So the more you watch Nawaz content, the greater would be the similarity index and thus the confidence while recommending that you would like it. And this keeps itself updating and improvising by itself. Considering the use cases where it should be used is if you were to make a movie recommender system and you have a lot of content incoming and you are not sure whether to recommend this to the user or not. In such a case, you don't have to consider much about the market popularity or the relative success of that item. And based on the properties, you can just recommend it to the user. This would actually make more sense when we go ahead towards the other algorithm and then the example section. There's one more term, popularity bias. It means affecting one's choices based on the market sentiment. So if let's say there's an actor whose movie no one really bothers about, but your user just watches all of his movies, irrespective of how it performs in the market. For such unique users, content-based filtering is the way to go. Because what happens is it just maps the attributes with the object's attributes. So let's say actor XYZ is liked by no one in the market, but your user likes it. Just because of that link, you can recommend that and cater to the choices of your user. But as with great power comes great responsibility, this has to have all the attributes in a well-defined processable format. So if you're like relying based on the director and your data set just doesn't have this field defined for most of the movies, your content based filtering would just fail. Like if your data set doesn't have director field and your user watches movies based on the director, you can't have content based filtering over there. One more scenario where you have to consider way too many parameters. Then you will have to deal with the complexity of integrating of all those attributes and coming them to generate the final confidence level for recommending it. So if you like have that rebel of a user who just checks everything, actor, actress, number of likes on its trailer, market sentiments, must have this director and must be performing well, at least 4 stars on the box office, then considering all this would have to be like much of a deal with the trade-off and the complexity. Collaborative filtering. This one deals most with the real life scenario. What we actually do is it keeps a record of your past likings as well as users similar to you. It keeps a set of information and makes a cluster of similar users and plays around the similarity metrics. That is, if you and your friend, both of you have watched movies A, B, and C, now someday your friend goes and watches movie D and apparently likes it. Since you both have gone for 3 same movies and now your friend has added a 4th movie to his list, the algorithm thinks that since they have the same taste, it would recommend the 4th movie to you as well. And this is what happens in real life, isn't it? You ask for suggestions from your group who have the same taste like you. and it just works. This algorithm is also known for that and is termed as social filtering, as it filters its output based on the social information gained via similar users. Coming to the backend part, it actually it calculates the similarity between users and assigns a weight based on the likings and that uses for delivering the confidence level. And for this, it uses Pearson correlation similarity. The major advantage for this would be that if it doesn't need to store too much of information for any item under consideration. In the movie example, like you have to store your director, your producer, your actor, and everything. But if you just can't have that power or no need to store that all that data, collaborative filtering is the way because it just compares with the similar users. Thus, it is said that it doesn't require a lot of domain knowledge, as it simply considers the likings of similar users based on the social interaction to things. And it works well in case whether we have newer attribute defined to a particular item. We don't have to consider much of its weightage as it is not attribute based. Please keep in mind that it was an introduction to new item itself. Here we are introducing an attribute for an item. So it doesn't matter much who the director is or we introduce the singer for the title song. If your friend who has a similar taste likes it, you will like it too. But one major drawback we have to deal with is for the new user. Since we won't be having much information about the taste of the new user, it takes a bit of the time and to fit it to the defined cluster. That is termed as the cold start problem, where you don't have where you don't know where to start recommending from. So the standard advice is to follow trending and evergreen popular and hit items. One more use case for drawback is that it considered popularity bias. So if your cluster likes Hrithik Roshan movies more and suddenly there happens to be another actor which your cluster likes but you don't like that particular actor at all, but because of the previously same taste factor, that movie will also be recommended to you. This is termed as popularity bias. Here as a summarized comparison of both the algorithms, we can see red and green articles are read by both of them and they have similar taste. The blue one, when liked by one user, is recommended to the other one irrespective of the properties of the topic. And in the later one, it is purely based on the properties of the item. Since red and green belong to the same article, the green one is recommended based on the heads up given for the red one. We'll dig this more when it comes to examples. Just like everywhere, we see a trade-off between the algorithms and here as well. And thus hybrid one comes to the rescue. It tries to combine plus points of both the items and tweaks the algorithm in the favor of efficiency and accuracy. We have some more algorithms which aren't used much at an individual level, but are very useful when it comes to hybridizing two or more of them, with knowledge based, location based, demographics, sentimental improvisation. Talking of Netflix example, what it does is along with generating a list based on similar users, it also takes into consideration the genre of the movie, also the length of the movie from a list of cluster specific movies. If you are more of a sci-fi kind of a person, it will put more weight on that. And to be honest, it is the best approach. But again, trying to cater all the needs in model may lead to higher complexities and overfitting of data. Now, if you look at the image, it first fetches the popular liked items of the similar users and filters that based on the previously liked items and apply a knowledge base to it. Talking of knowledge base, it deals more with if this then this kind of rules, or if this or else this kind of rules to make decisions. One example of this can be again Netflix keeping a track of you usually stop exploring by let's say 3 a.m. in the morning. which is actually just midnight and chill for millennials. Now, someday you log into your account at say 2 a.m. So it would actually kind of run the knowledge base and try to recommend movies of relatively shorter length because it knows you usually log out by 3 a.m. or something. Uh, so it would recommend shorter length movies which can be finished off by 3:15, 3:30 so as to meet your requirements. This is what Netflix, this is why Netflix keeps growing. Architecture. Talking of architecture, this is how the data flow goes through the architecture. We have this huge source of information as our data sets. Considering a movie example, you would need a lakhs of data rows and their information to make it an efficient model. Each data row then undergoes pre-processing phase to format the data in the desired format and to extract useful attributes for filtering. Thus, the item description and subcategories help to pass it through the analyzer that analyzes the discrete data and generates an item knowledge base in the structured manner. Now you have the required data ready with the labeled parameters. Parallelly, what your system would be working on is data for user profiles. Each one of the users is studied very minutely so as to provide the best of the results. Your likings, dislikings, ratings, rewatches, skips, everything is stored to analyze and make a virtual network with other items. Each user is like considered as a separate entity or a use case and puts them into similar cluster for building a correlation amongst them. And similar to item databases, a user databases is also generated for mapping these similarities. All this data is now used by the filtering component to filter out the data based on your algorithmic strategies. The recommendations are generated based on the rules defined in this filtering engine, and the filtering output is provided to the output to the user. What happens in most of the cases, the output data is fed back to the filtering engine with a sentiment of that result. If the user is happy or chose or like that item, its confidence would boost up and that it's working on the right direction or a proper direction. The other way around, if the user doesn't happen to like the resulting output and gives a sad reaction or just rejects them, this adds a negative feedback to the filtering engine, which eventually leads to improvisation towards better efficiency. So you see, every minute detail matters and it's important for a high level accurate system. Okay, so much of conceptual knowledge, right? Let's jump a bit towards tried and tested methods, and this must be really interesting. This was done as a part of a project for analyzing in various entertainment domains. So the data set was taken from Kaggle. You will find a lot of open source data sets for working in machine learning projects. The best thing about this data set was that it had a lot of additional information to expand our attribute search and property mappings. Along with movie names, release dates, collections, ratings, information about cast, crew, and genre was also maintained very well. So you see, here is where you try to filter out thriller movies. It very elegantly provides you the top ones based on the social popularity. You can see names like Inception, Prestige, Imitation Game, and whatnot. Now, to achieve this, what actually was done is first the data was structured in a proper format. That is, we tried to fill out all the null values which were feasible to do so. The data was labeled in a manner that it makes it easier to iterate through all the parameters. To avoid too much complexity, we simply removed certain movies having no or very few ratings, like movies having only two people rate them on the entire world. This should not be done on an enterprise level, but we had to do this considering model training, hardware availability. After all the necessary pre-processings, our data looked like this. You see, there are a lot of parameters useful while considering users having a diverse taste. It has budget, description, genre, languages, dates, and almost everything that is associated with a movie. And this generates a list of qualified movies, sorting them based on the popularity and trending nature. In such a case where you are in a pilot phase or you have a new user coming in and you don't really know what to recommend, you can go for this list as these are some most popular and trending movies. You can always see this list Netflix and similar platforms. Who wouldn't like movies like Inception, Interstellar, Star Wars, Shawshank Redemption? An Indian data set would like show more movies accordingly. We do have a bit of Indian data in this, but not much. One can find paid data sets on enterprise level projects as well. So after all the pre-processing, we can have filtrations like this. We had a look at the like we had a look at few minutes ago. This one gets you movies belonging to romance genre. We have DDLJ at the top and movies like Titanic, City Lights. Now, this is interesting. Like, our new user has watched a movie now, and after watching movies like this, the algorithm tries to find more such movies based on the similarity metrics that we discussed. It keeps on updating in a different manner for different users based on their choices. After watching Godfather, the algorithm is trying to suggest to go for Godfather Part 2, Part 3, and similar other movies. Same with more edition of movies. For Fight Club, we have a Raging Bull, and for the Dark Knight, we have Dark Knight Rises, Batman Forever, Batman Returns. Now, I would like to emphasize more on this thing that it is trying to correlate movies based on the title and genre, mainly with the summary as a secondary weighing parameter. And to improvise this, when you actually consider the cast and crew as well, the recommendations for the same movies are changed now. Previously, we had all of the Batman movies for a user who has watched a Batman movie already. Now, in this transition, we have movies like Inception, Interstellar, which are already like directed by Christopher Nolan. And this is how you need to take steps toward better accuracy. By trying out various combinations and methodologies, some might just work with 5 to 6 parameters. Some would not be enough even with 20. It all depends on what service you are catering to. So this summarizes to one thing like if your user, if you're just going for the title, anyone who has watched, let's say Krish, the system would recommend Krish 3 and so on. But when consider the director, the cast and everything, a Hrithik Roshan movie directed by Rakesh Roshan doesn't limit to Krish, but it goes way beyond like that. So when you add more parameters like songs, singers, composers, your list would get updated and this would just give you better accuracy. Ratings. Now, like we introduced one more parameter. Now our user has spent quite a few time with the system, like it has been some months, let's say, and has rated or liked certain movies. This log defines all the ratings or likings based on user ID and movie ID mapping based of the rating. Now that every user has his or her own taste and they both recently watched Avatar recently, considering the peer likings and the past likings, the filtering machine recommends somewhat different movies to both of them. So we see we have movies like Star Trek, Aliens, Abyss for user 1, whereas user 500 is being advised for True Lies and Titanic, as he or she might have like shown a bit of inclination towards romantic movies. Similar things we tried with TV shows as well. We faced a few different parameters being given importance here, namely runtime of the show and the number of seasons. This brings out the difference between binge watchers and not so often viewers. When you consider the most popular ones based on the IMDb rating, you have Breaking Bad followed by Game of Thrones. But when you tweak a bit of sentiment, like people actually love that show irrespective of what it is being rated as, we see Game of Thrones going at the top, followed by Breaking Bad. Moreover, we see shows like Sherlock and Westworld coming higher to the list. Sentiment is a very important factor when you are working on any social projects dealing with AI. Sentiment helps you improvise your model. Social sentiments tell the significance and the popularity of them. We see like actors like Sushant or Ayushman might not have records like most of the well-established actors, but their market sentiment is way too high. So our engine needs to consider factors like these as well. Whereas user sentiment acts as a feedback to the model. If you recommend a thing and user tends to like it, it provides a positive sentimental feedback to the model and boost up the confidence for going in the right direction. The negative feedback would do the vice versa and provide a negative direction, a negative sentiment feedback, and ask for a better results next time. I came across one such high competent use case where there would be cameras in restaurants. And whenever any customer eats or drinks something, it identifies the facial expression and recognizes the object on the table, and it tries to generate sentimental models to score the taste and what is it more liked by what kind of users, so as to plan the menu and chefs accordingly. There are already a lot of robotic chefs in quite a few restaurants for experimental purpose as well. We found some Indian TV shows as well. Here are some of them. We have Sacred Games, Mirzapur, Little Things, Inside Edge leading the board. Similar genre-based filtering was done for TV shows as well. For horror, we can see Stranger Things, The Haunting of the Hill House. For thriller, we have Breaking Bad and Sherlock. Similar things were done like movies. We also tried a few things with songs. Though a lot of people don't usually follow songs based on movie, there were still a lot of people who liked songs sequenced belonging to the same movie. Otherwise, the most weight parameters was the singer and the actor. As we see most searches like Maroon 5 all songs or Imran Hashmi all songs, Salman Khan all songs or Arjit Singh all songs like that. And then the type of music or band it has, which could get you the eventual filtered list. There's a separate kind of filtering for location specific suggestions. That is the demographics. If you are a beach person and you surely visit a beach whenever you go to a new city, it would recommend beaches to you on any other new location. Or it just like fetch you a list of popular places based on the based on the type of your current location. If I click on Hindu temples, it pops up all of them based on my choice. Similarly, it comes up with a list of popular cafes around you. So yeah, it considers geographic location, prompts and filters out the type of usually visited places and recommends accordingly. So that was in brief about recommendation systems. And I would answer any queries, but before that, talking of AI, we cannot miss OCRs and chatbots. So I kind of wanted to put some light on that as well. Let's first talk about object detection. This lies more under the machine learning and the neural network section. I'll start with an example. Few days back, I opened Google Photos app, which must be present in almost everyone's mobile device. When you go under search section, it will get you a list at the top with all the faces and all the pictures saved in your device or drive would be sorted as per those faces. There's nothing new, right? A lot of softwares can detect faces. What I really liked about Google's face recognizer is that its accuracy is just damn too high. I mean, there were group pictures where even a human eye would take few seconds to recognize someone, but this amazing engine has all that sorted out. And it doesn't stop here. It was also able to parse those images from the WhatsApp group icon for any screenshots I had. I mean, this is just astonishing to see that level of efficiency. Nevertheless, it was also able to map these faces even from a picture 5 years ago. There happens to be a drastic change in a facial features in such a long time. Similarly, like faces, a lot of other objects can also be detected for various use cases, and that comes under object recognition. There are a lot of firms out there working on these kind of projects, and soon deep learning is going to be the next job seeker. So this is the example about Google Photos that I was talking about. For those who are more keen towards understanding the difference between machine learning and deep learning, it's just like deep learning is a subset of machine learning, or is itself also a machine learning, but with different requirement and capabilities. Though machine learning models improvise themselves via the learning capabilities, they still need some guidance. In some cases, if the algorithm goes in a wrong direction and is unable to make itself better, the programmer has to step in and tweak some of the code to make it work in a desired manner. And you would need to have some parameters predefined which tells the model that its prediction is inaccurate. Whereas a deep learning model can itself determine if its output is going in a correct direction or not based on the neural layers defined in it. Deep learning purely works on the basis of these layers, and usually an increased number of layers turn to a better efficient models based on the nature of the item under consideration. Again, self-learning, like deep learning itself is a much wider topic of study. Coming back to OCRs, one can find its interesting use case is one of the most popular and widely app, Google Maps. Those satellites actually recognize the vehicles on the lane and thus are able to provide such highly accurate information about the traffic on the road. I mean, out of so many objects on the earth, we have buildings, trees, people roaming around like some shops and whatnot. It also knows how to recognize the vehicles on each and every road and get you the time estimate and changes color to red and amber based on the traffic jams. Another amazing example which I have witnessed is at airports. Like during the security checking, your bag undergoes a belt which has this machine to recognize all the objects. Even that one has a pretty good accuracy. I mean, there was a guy just ahead of me and he had scissor along with his shaving kit. And that was like pretty much enclosed with a lot of stuff above and below it in the bag. Still beating all those objects, it was able to point that out. Amazing technology. Even the buzz of self-driven automatic cars has a lot of dependency on object detection. Accurately analyze and decide where to make a turn and which direction to move the steering wheel in case of any pole, animal, or any other object. Also, to determine the traffic signal and thus the light color to decide whether to apply a brake or need to keep going. What I really want to focus is the text recognition part of it. Just like these objects, there's a lot of need to recognize letters or alphabets printed or written anywhere. The motivation kind of came from one of the problem statements defined by AICT during Smart India Hackathon. A lot of firms have their data stored in form of physical papers, bank account opening forms, university admission applications, government ration cards, and many other domains. We have been filling in these physical forms since a lot of time till now. Many have started following the digital approach, but even for that, you need to migrate all the data to the data store, right? And imagine the amount of human effort required to manually enter all those lakhs and even crores of applications into a system, data entry. And even after that, being ready to have that done manually, consider the case where there happens to be a human error or a mistake. Date of birth mistake takes ages to get rectified in government records, or a name, your marks, or mismatch of a digit in a bank account number. Scary enough, right? More applications would be your bank directly recognizing the figure of the check deposit machine. You just need to enter the filled check and you would directly get the deposit receipt with the proper amount, name, date, and everything like mentioned in the image. Now imagine someone sending in notes or images of blackboard or what a teacher taught today in the lecture. And by the end of semester, you have like hundreds or thousands of such images. Dealing and maintaining these images would be a really tedious task. How blessing it would be if someone could actually read all that data from those images, I repeat, images, and that get you a document ready in an editable text format. Sorry, sorry. This is something that is getting this is something that is getting a lot of development and improvisation focus in the industrial world, because the world out there has a lot of information in the form of images or something that can be converted to images by clicking simple pictures, just like those bank applications. Remember that Google Photos example in which it was able to recognize faces from a pic and from a screenshot of a chat as well? Well, Google gives one more option these days to read and parse the chat into an editable text format. So if you have any screenshot of a chat or anything you read from web application, you can just directly get it stored in a document you can edit or refer in future. So those pictures that you've taken from a blackboard as well, or from someone's notes, you can actually make a nice document of it. This is what Cam Scanner and Adobe Scans premium versions are known for. There's one more use case which is kind of known as the necessity origin for OCRs to read the number plates of vehicles, so that the cameras on a traffic signals and roads can like, capture any crime, accident, or breaking of rules, and the OCR can directly read the numbers on the number plate. This automates the procedure of like, this can really automate the procedure of getting directly fetching the numbers from the number plate, going to the RTO database with that number and sending an email or SMS to the vehicle owner with a challan and fine amount corresponding to the rule broken. No need of physically catching hold of these and tearing out challans. Automation is the future. This way you can convert various bills that we have on retail shops, clothing shops, medical shops, etc. We'll just click an image of the bill. It knows where the amount in quantity lies. Where do we have the name of the item, and it stores everything in your financial ledgers and associated softwares. So this is like a small tiny form of project I mentioned about SIH. We had a data set of 8 lakhs images, and this is what the USP is. You have a handwritten variety as well. Like the market out there is more accurate towards the printed text, but there's a lot of development going for the handwritten text as well. Some people write alphabets a bit curvy, some bold, some bit italic, small, big size. The more the dataset images, the more variety you can cover. As I mentioned, we had like 8 lakhs of data images. In this image, we can see the image undergoes image processing. That is, all the text is line segmented. Your image pre-processing algorithm needs to know the line spacing, which is like quite generic, so that it knows where to fragment the data between two lines and how to differentiate them. Further, it tries to fetch individual alphabets and run through the machine learning engine to predict what it is. So you see, the A here is being mapped to the A learned from the model training by the algorithm. And this way it keeps on converting the text in the topic. Now you know the working of that automatic check deposit machine found in one of the banks. Like those who don't know, what happens is you directly enter your check that you want to deposit in your account in that machine. In like 10 seconds, it gets you the image of the check with an OCR run on it, having all the data, name, date, amount itself, and it just directly deposits into a bank account. So no more manual intervention or anything like that. Technology just keeps making our lives easier and easier day by day. If at all you have tried to convert a PDF to Word document and get frustrated, remember this OCR. There's one more topic which I consider as the most prominent gift from the world of AI, chatbots. I want to enlighten in a bit summarized way on this as well. Post that we can go ahead with Q&A session. Chatbots are also known as the human conversational agents. You see these chatbots everywhere, from bank applications, service-based web portals, to giants like Siri, Alexa, and we have Google Assistant. Soon, the world is going to be ruled by physical robots in the work-driven domain. And imagine the amount of AI's conversational feature required by a fully functional end-to-end bot who has human-like thinking capabilities and talking power. Not only this, chatbots are being given a lot of importance in the field of mental and emotional health development, where people who are sad or feel depressed can talk to these bots, and this has become a topic of buzz around the world. There are many such products available out there. Where these chatbots are ruling the customer service world, we see a lot of medication followed using these chatbots as well. They have all the data in their knowledge base and they perfectly apply all the rules and fetch you the desired response. So we have doctors made by engineers without any degree. Plus, with translating APIs, you can just convert these request and response in any of the languages or based on just one REST HTTP call. Languages are no more a barrier. Any conversational bot depends on these three things to understand anything and everything. First is intent, second is entity, and third one would be context. If I'm able to provide an overview in one sentence, the intent is the action described in the sentence, and entity deals with the attributes of that action. Here is an example. It says, show me yesterday's financial news. The action here is to show. Show being a verb, there has to be a noun associated with it to complete the sentence. So we have news. Thus, show news become our intent, making it an action. And the attribute of that action would be like the details stating yesterday's and financial. The news can be political, education, etc. So we choose financial. And for detailing it more, we choose yesterday. So yesterday and financial become the entity. I'll repeat once again. The entity is let's start with intent. The intent is the action and the entity is the attribute of that action. The action here is show news and the attribute for that action would be entity. It is yesterday's and financial. Attributes and action. We'll dig on more on this. This way, like for all the sentences that your bot would receive, it would convert it into entities and intents and will try to understand the context of the inquiry. There are small talk intents as well as those are generic ones. Say hi, hello, how are you, bye-bye, thank you, and all those. We call them casual intents. The ones like they usually complete a sentence by making it a query worthy, we call them business intents. And coming to context, context is something that is responsible for keeping the track of and maintaining the flow of conversation. Basically, it drives the talk. You can't expect a chatbot talking about something related to mobile phones, certainly responding with some information about, let's say, current weather forecastations. That is something a context needs to take care of, understanding the query and sticking to the current flow. Chatbots thus is about defining all the rules and trainings of what to respond when. The technicalities of the chatbot lie in their NLU capabilities, that is natural language unit. Yeah. The component that actually deals with human simulation of things. There are two major tools we can say available to gear up with chatbots, Rasa and Google's Dialogflow. I'm sure there are many more, but these two are doing wonders in the marketplace. Both of them pretty much do the same thing when it comes to the core part of the chatbots. The difference lies in the integration capabilities and the development interfaces. For Rasa, you need to set up the entire system architecture along with all the Python libraries in your machine. Whereas Dialogflow is like Google owned and is directly hosted to the Google's cloud. Just like Drive or Hangouts, you can directly log into Dialogflow and start working on it. It gives you an UI so that you can spontaneously start building your agents. Agents are the ones that take care of your intent and entity extraction from fulfillments. Non-techies can also build a chatbot using Dialogflow, whereas you require high-end programming knowledge to work on Rasa. But Rasa being like community driven, it is more open source and has a lot of information and projects available on GitHub repositories. Whereas Dialogflow being Google driven, one has to go for the premium versions to have all the features. There's one thing I liked about Google the most is it provides a direct integration with most of the apps like Messenger, Telegram, your web apps, and many more. So you don't have to worry much about the integrating it with an UI or a third-party app. You just need to develop your model, and chances are it can be directly leveraged from some UI. Talking about Rasa in detail, the architecture works something like this. You have an interpreter on receiving a message whose job is to understand the message and extract the entity and intent in the form of a JSON object with keys defined in the dictionary, like the one in the image. So I'm looking for Mexican restaurant in the center of a town. So it's looking for something, and it's looking for a restaurant. It would be an intent, and the attributes like what kind of restaurants, Mexican, and where the restaurant should be would be the center of the town. So this completes the entire sentence with intent and entities. When the message goes to the tracker, the point number two, who keeps track of the context of the conversation we talked about, so as to maintain the flow of the conversation. The tracker internally is in touch with the policy component, which runs certain rules and tells the tracker what action it needs to perform. If it's a message, like if it's a new message, it will probably respond with something like, "Hey, I am bot ABC. How can I help you?" Or can like just provide with a list saying, "There, these are my functionalities. How can I help you? These all I can do." And when it's an end of a conversation, it responds with welcome or goodbye and tries to understand the sentiment of the chat. Sentiment we have talked a bit in the previous minutes of the session. I'll come to that in a bit again. For any mid conversation request, it simply returns the responding action that needs to be performed. Rasa also started delivering UI integration these days, but I guess that is still under development phase. Rasa has all the trainings and guidance available for free on their website rasa.com. Coming to Dialogflow, Dialogflow has its own microservice based architecture and deals via API. So there are a lot of already developed APIs that you can find in case those fit in your product, like weather information, sports information, etc. And it has inbuilt text to speech conversation. Also, the language translator as well. Everything that you build with a chat intention in the mind, you can simply make that oral on just one click. It will start responding your voice based queries as well. So you're just like while developing, you don't have to worry about it being voice based or text based. Your Google Dialogflow keeps takes care of everything, and also the language as well. You just translate your model in English language. You train your model in English language, and you want to launch it in, let's say, in South. It will just have an API of Google Translator from English to, let's say, Tamil. It will do the job for you. And if you can see this query, like if you can see this conversation, the initial query doesn't have a proper entity. I mean, the user is asking for account information that describes your intent, right? Uh, that it needs some account information, but exactly what type of information that is missing, the entity part. So it determines that one of the parameters is missing to run the check info intent, that is the name of the intent, and it asks the user what kind of information do you need. Once it has the entity, it will run the corresponding intent and gets to the response. So if the user would have typed or said, I need account balance, the what information do you need for your checking account would have been skipped, and directly it would have been shown with the balance. The data flow goes something like this. User submits a query for a conversational component via text or speech. The query that is passed via your UI integration to your API service. Then there is more of an internal communication from your API to your service and to your database to decide any response that needs to be computed, if any. When it has all the required parameters, it simply extracts them and passes the information to your UI via your service. and that becomes the response to your user's query. We talked about sentiments, right? Sentiments in general, we all know, is the feeling. Feeling can be positive or negative. If a movie is doing good in the market, it has a positive sentiment and vice versa. What significance we have in chatbots is your model tries to analyze the sentiment of the chat, and there is always a sentiment chat score associated with it, ranging from -1 to 1. -1 being very disappointed, 0 being neutral, and 1 being the happiest of the service. This score acts like a feedback to improve the model responses. So if the user uses phrases like "No, I'm not satisfied," or "Tell me again your response," "Can you explain me more," or has rage in his words, or simply takes longer to chat with the bot on one topic, stating it is taking time for the bot to understand and appropriately respond with the query, your sentiment score would go in negative direction. And if needed, necessary amendments to the logic must be done to improve that. Whereas a positive feedback boosts the confidence for going in the right direction. Usually, bots have a live sentiment score, and there's a threshold. That is, if during the chat the score drops, let's say below -0.5, you can immediately engage a live agent to keep a goodwill of your service. The entire topic is known as the study of sentiment and analysis. Here are some of the snippets from Google Dialogflow interface, and these are the UI integrations. We have Viber, Twitter, Telegram, and Slack available over there. So yeah, we emphasized on AI and few of its wonderful use cases. Now we can jump to Q&A. And as I mentioned at the beginning, since a lot of juniors are in touch with me and keep asking me about placement guidance, I would be happy to take that to the wider forum and address that as well. And my special thanks to the IT department for always supporting me throughout my college journey and now giving me such amazing opportunities via these platforms.
Thank you, Vishal, for the talk. That was extremely informative and detailed. I'm certain that it will be of immense help to the students. So, without any further ado, I'd like to commence with the question answer session. I urge the viewers to post their questions on the live chat box. We'll try to answer as many questions as possible.
Yeah, sure.
Okay, so the first question is from Faizan Qureshi.
Okay.
What are the prerequisites to become an AI programmer?
Okay, so talking of like gearing up with AI, the first thing you need is certainly a willpower. You need to gear up with a solution or a problem statement that brings up a lot of interest in you. And coming to the technical portion of it, you can start with calculus and predictive algorithms and like Bayesian algorithms and all that stuff. You need a quite good amount of knowledge of statistical maths and certain like discrete mathematics and that kind of stuff. And when it comes to the coding part of it, Python is the way to go.
Okay, so what are the resources that you referred to for learning the mathematics?
Udemy. Udemy is
Udemy.
like best, yeah.
Okay, thank you. The next question is from Rohit Kundani. Rohit says he wants to start with AI and ML, and he doesn't know where to start. So, could you please guide him through it?
Okay, sure. Like as I mentioned, you need a great willpower to start with it. Like you can maybe start with a program or problem statement that brings a lot of interest in you. So for me, like movie recommendation systems and songs recommendation systems, like it brought a lot of interest in me. So it brings a lot of willpower in you. You can like take up a similar problem statement for the same, and then you start with Python. Like reinventing the wheel is not, you should is something you should avoid. So you go on Python libraries what others have implemented, and maybe you can try on certain GitHub projects or Bitbucket repositories where the project is kind of in the middle of something and you need to collaborate to that stuff, kind of a thing. That's where something should like someone should start with AI and ML.
Okay, could you guide me through how you picked up learning AI right from second year of your college?
So I had a lot of interest. I kept reading about a lot of use cases. There's a website called leadingindia.ai. It provides a lot of use cases. So based on that use case, talking of the fundamental and functionalities of that particular use case, I went on reading what exactly a human would do. So when, for example, talking of a chef, as I mentioned in one of the examples, is he would first determine what kind of ingredients he would require. So how a human action performs, the way, similarly I tried to find out the way how a machine can perform in a similar way. So I geared up with that and went on ahead like with libraries, what kind of technicalities lies behind those particular examples and functionalities.
Thank you. The next question is from Mrs. Asha Bharambe, who has taught us both a few subjects. So
Yeah.
her question is, just a second. Any tips that you can share for participating in an AI or ML competition or hackathon? So what are the tips
Yeah.
that you can share?
Yeah, like thanks, ma'am, for bringing that up. Hackathon is, I believe, is a way to go because the things that you learn in a hackathon is way more than you learn in an entire semester. Because for those 24 hours, you are way too much engrossed in your solution and the problem statement that you try to dig up, because you have to present something on a stage. You try to dig up a lot of solutions and a lot of things that you keep to learn. When you Google, there's a website, upcominghackathons.org. There are a lot of happening virtual hackathons happening as well. And when like the lockdown gets over and everything becomes normal, there will be a lot of normal hackathons that will be there. So upcoming hackathons.org and Mumbai hackathons is the way where you can find a lot of problem statements. And if there's a like free theme hackathon, you're ready to implement anything, then I would suggest pick up a ML hackathon and maybe try to find similar project that is already being implemented and try to improvise that project, and try to add a USP as well. For example, if a chatbot, or talking of OCRs, there's a lot of OCRs available in the market that do it very well for the printed text. But when it comes to handwritten text, a lot of OCRs do not do that great. So like try to develop that kind of USPs as well.
Okay. So Shivam Singh has a question. What is the difference between AI and ML?
So a lot of people get confused about it. AI and ML. ML is certainly considered as the subset of the AI. When it comes to AI, it's the ability of a machine to think like human, to think and perform like human actions. But when it comes to ML, it deals more with the adaptive and the decision part of it. If I were to like give an example, for example, playing chess. Playing chess is an AI characteristic because you are able to think like a human. An artificial intelligence is what we call, but when you try to increase and decrease the level, it adapts accordingly. So when you go for a beginner level with a bot, it plays accordingly. That's where the ML part comes. So that's where AI and ML differ. Like, majorly AI is considered as a superset of ML.
Okay. Hmm.
Yeah.
Siddharth Chucky has a question. He says that the primary problem, according to him, is that uh, this is a long one. Please bear with me.
Sure.
So he wants to develop a model based on user behavior, and he doesn't know where to find the data for it. So what he says is that most of the time the data that is required is not present in good format. So how do you overcome that situation?
Yeah, that's the main reason rich is getting richer and poor is like staying there. Because consider an example for say Google and Facebook, they have a lot of data with them, so they're able to like engross with it and go ahead with all the implementation and all. But majorly for the use cases that are already implemented or already under development, you can find data sets on Kaggle and similar websites. For OCRs, we like faced quite an issue in handwritten text. So we went and collaborated like similar data sets from various websites and made some of them with manual intervention as well. So if there's nothing and your topic is totally new, I guess like making a data set is the way to go by yourself. It's a tedious process, but that's the only way to go. Otherwise, if there's a paid option available, that's fine as well.
Okay. So Nagesh Nayak asks, can you throw some light on object recognition domain, which you have mentioned in the video?
Yeah, object recommendation, like for example, talking of let's say the cars that we mentioned, the self-driving cars, we keep talking about them. they have to determine everything, right? When there's a pole in front, when there's a human in front, or there's a traffic signal, you have to determine the color of the traffic signal as well. So that's where the object recognition plays a major role. And the airplane example that we mentioned, and like if you consider the technology beyond 30 years from now, you can see humans, like robots taking over humans. So those robots will also have to have that object recognition capacities as well. Because if he or if the robot is like trying to do something, he must be able to determine what kind of object he is dealing to, or what is the kind of a human that is dealing to, what is the object that is trying to pick it up or place it anywhere in the room. So that's the significance of object recognition.
Um, Pooja Prasad asks, uh, she wants you to elaborate on research directions and recommendation system using AI.
Okay, talking of research, apart from the entertainment examples that I mentioned in my session, like we can consider an example. For example, in health direction, there is a lot of research going in health direction. What happens is they try to map these objects with the disease. For example, people of these kind of characteristics. For example, if a people if somebody is obese and is short-headed, usually face this kind of disease, so they try to cure it beforehand as well. So this is one domain that is like or we can say these kind of people tend to react more on these kinds of medicines, so you can make a decision on that as well. So this is also where recommendation system research is going on. And another topic would be, for example, the entertainment that I mentioned. And for example, there's a lot of human sentiment and human psychology also going under researches. People of this background, this communication background, this for example, we should not say, but people of this religion or people of these kind of characteristics tend to perform these kind of crimes, so they try to establish their mental health as well. So these two are the major topics apart from entertainment that are going under recommendation system.
Okay. So Surendra Pandey has a good question. Any tips for non-CS branch students to learn programming and mastering any programming language so that they can get a better grasp on topics like AI?
Okay, so like with the advent of technology that we have, even non-CS backgrounds need to learn programming, because that's the only future for every engineer students, apart if they do not possess any kind of a major core skill. So when it comes to programming, what I always refer to my juniors and what I usually followed is you need to talk to your computer. If you're explaining to a kid what happens if you do something, what happens if you learn
What
programming,
happens if
if you want to do something, those kind of questions you need to talk with your computer as well. So a lot of people face these kind of these kind of difficulties when it comes to programming. Even non-CS backgrounds, they first try to like we learn algorithms and flowcharts, right, in our first year of engineering. That's the same thing that we are learning in our first years of college. Talking to a computer, for example, a lot of teachers give this example. If you want to start a bike, what are the steps you follow? If you can tell those steps, like I'll put on the key, I'll start the ignition and like start riding the bike, and will control on race and clutches. If you are able to think something like that and you're able to teach something like that, that's the similar way you need to follow with computers as well. So you write that algorithm, and coding is just like converting that algorithm in an English or your native language into a syntax. Everything is same, like in Java, in Python, this would be done in the similar fashion because the core logic remains the same. But when it comes to the difference lies is only the syntax only. So with coming to the non-CS backgrounds who want to start coding, they first start talking with computers with your algorithms, and then try to build those small use cases that we learn in our first year of engineering, like Fibonacci series and all that stuff. Try to implement that as well, so you know how to talk your computer via the required syntax, and then you march towards such big giants like AI and ML. And if somebody wants to start, C programming must be the way to go, and on in parallel Python is also good.
Surendra has a follow-up question. So he believes that just a second. So half the programming tutorials for any language are intimidating for any non-CS student. So can you please tell me how you learned programming languages, and how your approach was.
Yeah, like it started with a choice, because when I was a kid, what happened is, like, I was more keen into games when I was a kid. So I used to wonder, like, when I tried to hit a six, it hits a six. When I tried to hit a four, it tries to hit a four. Or when I tried to, like, jump a Mario guy, he actually jumps. So that's something that drives me towards the programming thing, and you need to find that as well. And like, that was my approach. But when you come to the higher studies section of your career, you need to develop certain use cases. And as I mentioned earlier, you start following what's already implemented, and you try to improvise that. And like, what exactly was the question, apart
Oh,
from
yeah.
what I missed?
So it seems that he has tried some courses online and he didn't find it to be good. So he wants an alternate approach to learn the programming languages.
Yeah, so just following up those theoretical questions and concepts is not the key. Whatever you learn, for example, you spend 2 hours on learning a concept, you actually need to spend 4 hours on actually practicing it. I always tell my juniors, whatever practical labs you do, a lot of teachers already know that we, like, including me as well, we a lot of students copied our seniors programs or tried to Google it. But what I realized at the later stage of my college career was, when you actually try to spend those 4 or 5 hours on implementing that mini project, or doing what a lab experiment is supposed to demand, you tend to grasp things very quickly. So if you are following if you're following a YouTube course or something paid course, and it doesn't seem to interest you, you simply switch to another source. But you keep on switching between 10 or 15 courses. The core thing remains, you need to practice. Because at the start of my career, in first or second year, I did not follow up any YouTube questions as such. I was following reference books, Rima Tareja, and all that stuff that we have for Java and data structures. When you try to implement anything, you just think of a question in mind and try implementing it. Because when you start implementing it, you realize, oh, there's a need of this particular thing. For example, coming to strings, which is considered as the basic part of Java. Strings, when you find such use cases, you actually try to you get stuck when it's you get stuck, because you're supposed to write a 10-line code. But when it comes to Java, there's a simple function for concatenation, for substring, and all that stuff. So when you start implementing those things, you have that necessity. Oh, this is something that should be there. And as a human, if this thing was available, I would have been easier to do that. Then you march towards, if there is some library available for that stuff. What I personally used to do is, like, I stayed in Ulhasnagar, and it used to take on an average 1.5 hours for me to travel to college. I used to pick up a coach or a hacker and question from my home, and I used to brainstorm throughout my journey. And after coming back to home, or when I used to get time in labs, I used to actually code it and realize where's the thing that is lacking. So you keep learning concepts, but at certain point of time, you start implementing, and you realize, okay, this concept should have been there. And if I was a human trying to solve this question, this would have been I would have helped me. And then you go to Google and find if there's something similar available to it. So summarizing to it, practicing and actually implementing is the way.
Okay, thank you. So Surendra has another question. What's the first step to actively start AI ML related programming related learning for beginners who are from non CSIT branches?
Yeah,
And
again. Okay, go ahead.
yeah, yeah. Yeah,
Go ahead.
and any tips to learning data such as an algorithms?
Yeah, for data search, like, you should actually start with data structures. Rima Tareja, you should completely go through Rima Tareja, because that's the best book for data structures. And then you start implementing the data structure use cases as well, the trees and linked list. For me, Amit Singh sir, like, did a very great thing at the start of our college career. Was he asked us to implement mini Facebook. So no UI, nothing. We do not have any knowledge of that, but he asked us to implement mini Facebook. So we started implementing of what we used to know at that time. And throughout the semester, what sir asked us to do is, the way you keep learning, you try to improvise that code of yours. So at the end, the thousand line code, which was done manually, for all the functionalities was like some 300 lines of code, because we learned a lot of available libraries. We learned about a lot of efficient things, and like go start with Python, then go jump to the meanwhile start with data structures, parallelly start with Python, and then jump to these higher level languages with a very nice use case that brings up a spark inside you.
Okay, thank you. The next question is from Vishesh Mittal. How to start working on an AI research paper? So he has an idea as to what is to be done, and he has done 2 3 projects on test classification, but he doesn't know how to start, uh, how to begin writing an AI research paper.
Okay, for that you need to read a lot of AI research paper, and there's no as such predefined format for a AI specific research paper. You just try to implement or write what it is trying to cater to. For me, for like any AI research paper or any kind of research paper, what the most interesting part is what it is trying to cater. For example, if there's something available in the market, you're trying to write a research paper on the same, people won't be that much interested. But if your problem statement is trying to cater something that is trending in the market or has a need of a solution, you try to elaborate that particular solution first. So if you go on Google and just simply type for some research papers, the one thing that you'll notice the most significantly is the need is explained very clearly, because need is what that defines and drives the rest of the paper, and that's what it brings interest. So when it tries to cater the need, then the solution part comes into the picture. Because no matter your solution is of a great, like if you're trying to write a research paper on Facebook, no matter how efficient your solution is, it might be better than Facebook, but people won't read, because a lot of people are using Facebook and are happy about it. But if your research paper is something about LinkedIn, which is under improvisations, and they find certain ideas of improvising it, then it might be a hit. So need is what something you need to describe in a research paper, and then the solution in a very elegant way along with examples.
Thank you. That was very well put. Hemkesh has a question. What can be the future of AI?
Robots, like robots are gonna take over humans anytime in upcoming 20 or 30 years. We keep talking about these self-driving cars. We keep talking about robots. So in the lockdown period, you see people from Amazon and Zomato coming to your homes and doing the delivery. The AI future would be like replacing all of these guys and the middlemen for the robots to do anything. And like these self-driven cars and robots are the way. This is the future.
Okay. So now that the placement season is just around the corner, so could you please guide me through how you prepared for your placements, uh, and just how to approach the placement season and calm your nerves before the interview process?
You certainly can't calm your nerve as such, but when it comes to the beginning of the placement session, what happens is a lot of people try to implement or like build their resumes a month or like even 10 days before the first company that they are appearing to. What I suggest my juniors is you start preparing or building a resume at least a year ago. Because if in the seventh semester you're trying to building a resume, you do not know what you need to do to improvise it. When you start building on let's say sem 6 or semester 5, you know, these are the things are I'm lacking, or these are the things that can nourish my resume. So resume is the major important factor when it comes to these things. Like you need to be thorough about your resume, as if in the semester 5 you're building a resume, the next day you're appearing for the company. You need to build a resume that way, because that's when you come to know about the level that you are when it comes to placement seasons. The second important factor and the major factor is communication. A lot of technical people reach till the interview round and the HR round, but are not able to crack it because of the communication factor. Because you can be very well to put a solution in a technical manner or on a paper, but when it comes to conveying people for the same and convincing for the same, you need to have that communication factor. So if you're not that thorough with communication, you should start recording yourself you're watching yourself in mirror or talking to people, because communication is a really really important factor. The third one is people usually forget about or start late with it, is aptitude, because that's what that keeps your mind running. Because we all came via certain entrance exams like CET and JEE. So the primary thing and the functionality of those entrance exams is to keep your mind running. When it comes to aptitude, that's what they do. So like people start with aptitude 10 or 15 days ago, because they feel the formulas hi hai, ho jayega and all that stuff. When it comes to placement, at least 2 or 3 months before your placement season, you should start with your aptitude as well. So communication, your resume should have a mix of any company would prefer a guy with an 8.5 pointer and a lot of extracurricular activities, because it resembles the work life balance that you're maintaining to, rather than a guy having a 9 or 9.5 pointer but no extracurricular activities. So your resume needs to depict what your personality is, what your charisma is. So resume, communication, and aptitude.
Okay. So I'd like to wind off the session by just asking you one last question. Now that it has been a whole year since you have passed out, how do you look back on the 4 years that you have spent in college?
Yeah, so that's a very nostalgic and emotional question, because I miss my college a lot. Because a lot of people, if they know, I was in Bangalore for 8 months after graduate, like after my last exam for my home location. And I used, like, whenever I used to come to Mumbai to visit my home place, I used to go to college for some XYZ reason, for clearance purposes, for meeting certain teachers, like collecting LC and all that stuff. College is something you miss when you get out of it, and the support that I've received from my department and the entire college is just tremendous.
So, Vishal, I'd like to thank you on behalf of my college and the entire fraternity of management here. I extend a very hearty gratitude to you for throwing some light on how recommendation systems work. It is indeed a privilege to have you amongst us here. So that was it for today's session. I hope you all have some takeaways and are leaving with a better understanding of recommendation systems and how artificial intelligence plays a key role in our day-to-day life. I'd like to thank you all once again for being with us here. Please take a few minutes of your most valuable time to fill out the feedback form, for which you can find the link on the description box as well as the chat box, and earn the certificate for attending the session. Thank you. That's all for the day.